Hi there. So today I just wanted to do a short little video talking about how to debug WebGL shader programs. So it's just going to be short. I hope not to go on and on. So I'll do my best to not to do that. So this is just an example that we're going to give actually in class on basically using index buffers. We're not going to worry about index buffers. You'll learn that in class. I just wanted to show you how we can debug certain values inside the shader. So let's go ahead and we'll open up the code. So as you can see, let's go down to the shader here. So we can see that our vertex shader is really straightforward. We are bringing in a position through a buffer, and we're setting the GL position to that. We then, in here, have a, oh, sorry, I'm really sorry. I'm using the wrong example. My bad. Very similar, super similar. We have, in this one, a position and a color. So two buffers, and then we output a vector4. And in case you guys are still kind of confused, when we say in, it means that this in the vertex is coming in as a buffer. And when we say out, it means that this is going to kind of, if you think about out, it's almost like returning, meaning that this is going to be outputted into a fragment shader down here. So what we say is we go, this is going to be the GL position. GL position in this case is basically a reserved word in WebGL, meaning that the position of the vertices is going to be set to the position that comes in from the buffer. And those positions are defined, sorry, scrolled the wrong way. Those positions are defined right here. And then those colors are defined right there. And then the indices for the triangles are there. And you can see that we have two triangles, and that's why we get this nice looking shape. Or not two triangles, we have a few triangles. But in the assignment, you're going to create a pentagon, so you're going to create another triangle. But that's besides the point. In our case, we want to be able to figure out when problems go wrong in the shader. So in this case, in the fragment shader, we say, you know, here's our version, here's the precision we want for floats. We're expecting this in value, so almost like a parameter in a function. If you're used to, like, you know, just regular programming where we bring in a parameter, like down here, this init shader program expects 3 parameters. An in is almost like we're expecting a variable in, and we said out here that there was going to be an out. So we named them the same thing. We know it's coming in. It's going to be a vector4. Perfect. And then all we say is that we're going to have a vector4 out called frag color, and that frag color is going to be set to the O color. Let me just close Steam, that way, you know, you guys don't get this bugged by that. But in some cases, let's say, you know, we want to add a uniform value and we want to make it a vector3, and we want to call it, you know, diffuse color in this case. If we go here, we refresh the page, you know, everything's fine because we haven't done anything with it. We're just saying, hey, it's here, away we go. But what happens if we say take the diffuse color, and because it's a vector3, you know, the frag color is a vector4, diffuse color is a vector3, so what we need to do is we actually need to declare this and just slap on a 1.0, and the fourth vector, or the fourth value in this vector, represents our alpha, or our transparency. So when we do that, you can see right away that this is black, and you think, well, why is that happening? The reason it's happening, and this is what makes debugging in the shader really difficult, the reason it's happening is because this diffuse color is 0. It's this right here. If we were to put it in a value, is literally 0, 0.0, 0, 0.0, 0.0, and that's in the X, Y, Z, or in our case, since it's a color, RGB. So it's completely black, and this is what really, for me, what I use when I debug shaders. You know, if I have a value and I'm not sure if it's correct or not, I'll just slap it in as the frag color, and I'll just say, you know, go ahead and tell me what this is. And you know, we can do really funky things. We could say here, we could say, let's do an out vector3 and call like O position, which is really weird. But what we'll say is we'll say the O position is going to be equal to the A position. And maybe we're getting weird values. We're not sure about if the position is correct or not. In here, let's say we're going to expect a vector3 called O position. And what happens if we change this to our O position? We can see right away we get color, but what's actually happening here is this color is the representation, the color form representation of our coordinates, which is really cool actually, because if you look at it, this would be 0, 0 right here, 0, 0, 0. And as we move up in the y direction, we start to get green, which makes sense. Our g being the second value, y being the second value in a vector 3. And then as we move in the x direction, we get more r. And if we were to rotate it, we might, if we moved it in the z position, we might see some blue. But you can see right away that, okay, well maybe I messed up. Maybe up here I forgot, I forgot to do this weird position thing. And if I do that, well, we get black right away. So my biggest advice is when, and let's get rid of this position because it's really weird. Let's get rid of that. So, oh, and you can see not enough data because we're trying to say, put in a position and it's not working. Well, the reason this is throwing you an error, and you can thank, the code that's been written, is because of right there, common function 36. So let's take a look at common function 36. Right here, print error. This is a custom function that I've written in order for you guys to be able to get an error to show up on your screen. But this doesn't necessarily mean that this is going to happen for you. What happens down here is we check this when we init our shader program. I'm not going to show you the whole trace, but we check using that value. So if you ever get kind of a blank screen or you're not sure what's going on, well, this doesn't exist. It doesn't exist yet. So let's put our diffuse color, which we declared right here, but we know it's going to be black. And now we say, okay, up here, we've used this program. Now let's go gl dot, and I think it's uniform 3fv or something like that. Yeah, and then it's looking for a position. So then we could say that, and I believe, let me just quickly look at this right here because it's been a while since I did that, and let's just copy this. This is what I used over here, and this is just part of your guys's not assignment. It's going to be part of the exercise in lab. So I called it diffuse color. So let's just rename this to diffuse color. So what this is doing is we're saying that go ahead and uniform 3VF or 3FV is basically going to update our program. So this is the program. We're saying GL use this program, and then get the uniform location of diffuse color and set it to this value right here. So now if we hit save, we refresh, we can see it's green. And what's really cool and awesome, okay, we can see it's green because RGB. But if we were to make a mistake, for example, we were to set it to 0 or we were to set it to negative 0.5, it kind of gets weird and we think, well, what's going on? And a really cool trick, again, what you can do is if you're really not sure what's going on, you can go like this and you can say diffuse color dot y, diffuse color x, y, z, and we can see it's still not right. But if we do this and then we say, let's set this back, let's make this correct, and let's make this our thing, this will look normal. But let's say when we rendered it, we only wanted to test what the green value was. Well, then we would go for our y, or our second value. And when we do that, we'd see it's black, right? And so by returning this, we can return a color that represents in all the RGB kind of channels that one single color. Does that kind of make sense? I mean, I'm sorry if I'm kind of blabbering on and on. My point is, if you're ever not sure what a value is, even if it's something weird, even if it's like float, temp is equal to like 0.5. If we ever wanted to see what that looked like, we can put that in that argument, and we can put temp to this whole thing, and we should get kind of a gray, right? Does that make sense? 0.5, 0.5, 0.5. My point is, as you start to get into more complex shaders, you're going to get more complex uniforms, you're going to get more complex buffers, you're going to have textures, you're going to have all sorts of things. And I'm not going to show those shaders right now because that'll just intimidate you, and I also don't want to give you answers to assignments. But once you are in the thick of those shaders, it's important to remember okay, you know, maybe I have a function and it's returning the diffuse color, but when I get diffuse color, it's like, well, lots of students will go like this. Let me just quickly go like this. They'll say there's going to be diffuse, there's going to be ambient, there's going to be specular. This will be the last example, and then I'm done, promise. And what they'll do is they'll say, you know, my color is going to be equal to my, sorry, order this ambient plus diffuse plus specular. And away they go, right? And what they'll say is they'll go, this is going to be a vector. This is going to be 0.5, 0.0, and 0.2. Ambient is going to be, since it's ambient, we'll just go 0.1, 0.1. And then specular, for some reason, maybe we messed up our code up here. Specular, for some reason, won't show up. It just won't show up. And a student will look at their code and say, hey, this looks great. This is exactly what it's supposed to look like. But it's not. So it's important to kind of take your code, go one at a time, say, what does ambient look like? Okay, sure. What does diffuse look like? Okay, sure. And then what does specular look like? Oh, it's black. Okay, specular is where my problem is. Somewhere where I'm doing the math with specular, that's my problem. And then you can go through, you can walk through, and you can output those values as your frag color, and you can see it change. And if it's black, then you know that it's uninitialized or something is not correct there. You're either negative or you're uninitialized if it's black. If it's extremely white, then you're probably over 1 or something is going on. I hope this was helpful. I'm sorry if it wasn't. I mean, there's a lot of other debugging tools, lots of extensions and stuff like that. This is just how I personally like to debug simple WebGL shaders. When it comes to running OpenGL in C or Go or other languages, there's programs that you can run that will actually pick up on the WebGL shader, sorry, the OpenGL shaders and help you debug. And I can definitely share those. But this is just for the purpose of this course. Hope it helped, and good luck. I'll talk to you guys next time.